For today's quiz, we're going to talk about a Slinky. These are spring-like devices that can walk themselves down the steps. But for today's quiz, we're going to take and we're going to extend it as a spring. Just let it hang down. Now, this is going to be a very hard shot to get. It goes very far down. So for right now, I'll just use part of it and let part of it hang down. And the question is, if I wanted this to drop to the ground and race maybe a golf ball, which I have right here, should I release the golf ball and the spring at the same time here, or here, 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 or here? That's our quiz. Let me show you what that looks like. As always, mark your confidence and then list your explanation for whatever answer you chose, A, B, C, D, or E. Typical student responses include all of the above. Some will say, I should choose A, drop it at the top of the Slinky. Others will say, no, drop it at the bottom of the Slinky. They're starting at the same place. A, the ball is going to have to drop further than the Slinky, where E would end up being a little bit more evenly matched. Others might even say, wait, we've been talking about this center of mass idea, where all the mass of an object can be thought of as being right in the midpoint right there. So we normally get E, A, and C. Occasionally someone will put B, but I've never understood that one. And every once in a while, someone will say, no, it should be a little bit lower than the midpoint, which was D on our quiz. The student that said C is a really good idea. Remember, the center of mass allows us to think of all the mass being of an object being at one point in space. So if I had a Slinky and I put it horizontally like this, and I stretched it out and it were laying flat on something, you would pretty much take right in the middle. But remember, we are holding this vertically. And as this gets lower and lower, what I want you to notice is the amount of distance between each coil as it's holding up the rest. Look, it gets further and further apart. So between my fingers here, I get 1, 2, 3. Basically, I have 3 pieces of metal there. But if I were to take this down to where I started and use that same exact measurement, I might get, what, 10 or 12 of these coils. So each one of the coils is holding up all the other coils below them. So this is not going to be a linear distribution. They are going to end up spacing out further and further and further the more I extend this. So, and I'm going to have to go on a ladder and show you this. It's going to be a difficult shot. But the center of mass is not going to be exactly halfway between. Remember, these are being stretched more than these down here. So the center of mass is actually going to be in position D, a little bit below the halfway mark. I'm going to climb up on the ladder. We'll actually release this, and hopefully you can see this. All right, I'm up on the ladder, and I'm ready to drop this. Remember, this would be position A, B, C would be in the middle, D would be lower, and E would be at the very bottom. I'm going to hold it a little bit below the middle, and then I'm going to put this in slow-mo and get a better view of this. So let's go. All right, that's pretty awesome. It's amazing what these cameras can do these days with slow-mo. And we can clearly see that the spring is going to nearly hover in space, the bottom, as they're pulling themselves together until they get about even and then they fall off together. So the answer to our quiz was answer D, a little bit down below from the midpoint. What I'd like to do at some point is go through and see if we can derive the mathematics for that. So maybe that'll be a future quiz. But that's our quiz for today. Welcome to the Idealized Science Institute's channel. We are a nonprofit organization that strives to help teachers and students enact authentic scientific practice in their classrooms. On this channel, you probably noticed we have quick quizzes. Hopefully you've watched a few. But what you might not know is we also have long-form lessons. These are lessons that teachers can watch and enact in their classrooms the very next day. The Idealized Science Institute also has a vast array of other resources that can be found at our website, www.idealizedscience.org. There you'll find, if you're engaging in these practices and can possibly do long-term projects that can be presented at a science conference, we offer scholarships for both students and teachers. In addition, we also have a podcast where we take educational research. These are often very long. We break them down for teachers. They can listen while they drive. We also have the Idealized Science Institute's own book, a framework for practicing science authentically. We're also offering in-service training to teachers, so be sure to check that out and sign up if you can. In addition, we're going to be rolling out what's called studio boxes. These are our curriculum, and if teachers don't have the supplies, we can send them to you, and you can enact these and maybe send them back. Regardless, if you can make sure you hit subscribe and like, and if you have any comments, please leave them below. All right, thanks for watching.